Pause the video now, guys, and try question 4, looking at composite functions, okay, for natural log x and e to the power of x, okay? So pause it, have a look, give it a go, and then press play when you're ready, okay? Question number 4. Given that f of x equals e to the x, where x belongs to the set of real numbers, and g of x is equal to 3 log x, or 3 ln x, okay, or 3 natural log of x, where x is bigger than 0 and x belongs to a set of real numbers. Part A, find an expression for g f of x, simplifying your answer. So g f of x means I take f of x and I plug it into g. So g f of x, okay, we plug in e to the x into g of x, so we have 3 log e to the x. Now, natural log, okay, and e are actually inverse functions of one another, okay? So ln e to the x just cancels to just x. So this just simplifies to 3x, okay? Right, okay, if you're not sure, okay, natural log of e, okay, just goes to e, okay, natural log of e to the x, okay, just goes to x. So you have 3 lots of that, which is equal to 3x. What about part B? Okay, it's slightly more trickier. Show that there is only one real value of x for which g of x is equal to f g of x. Okay, so what is f g of x? So f g of x, so I'm taking g of x and I'm plugging it into f. And when I do this, I'm going to have e to the power of 3 log x. Okay, okay. Now, from before, e to the log x just cancels, okay, to give me just x. But here's the key. I can rewrite this as e cubed multiplied by e to the log x. Using the rules or the laws of indices, e to the log x will just be x. So you'll have x e cubed or e cubed x, okay? So we have 3, okay, x equals x cubed, x e cubed, okay? Subtract this on both sides, so I'm going to have 3x minus x e cubed is equal to 0. I'm going to factor out the x, so we got x brackets 3 minus e cubed. Well, 3 minus e cubed, guys, here is just actually equal to a number, okay? So we can see that the only real solution to this is when x equals 0, okay? When x equals 0, then it satisfies both equations, okay? When x is 0, 3 times 0 is 0, and 0 times e cubed is also 0, okay? So this is slightly more, it's quite like a sneaky, okay, composite functions question. Again, if you're unsure, please obviously rewatch it back, okay? But essentially, for part A, we know that the rule is that natural log of e to the x just simplifies to just x, because natural log and e are inverse functions of one another, okay? So they're actually a reflection in the line y equals x, okay? They have the opposite domain and range, okay, of each other, okay? So natural log of x and e to the x are actually a reflection in the line y equals x, okay? So if you're interested, okay, a log graph looks like this, okay, passing through the point here 1 0, and then e to the x graph looks like that. Okay, that's a rough sketch. Across the y-axis at 1, okay, but they are a reflection in the line y equals x, okay, So they have the inverse, okay, domain and range, okay, they have the opposite domain and range of each other, okay. So this is the line of roughly at y equals x, okay, and this is a sketch of e to the x and natural log x. Okay, so obviously I revised how to sketch and how to plot e to the x and natural log x, okay, because they might have a question in the exam where I ask you to like sketch natural log x, okay, or e to the x. Okay, but that's it for me today, guys. Okay, all the best for your revision. Good luck for your exams, and I'll see you again. Bye for now. Take care. All the best.